Hi, in this video, I'm going to show you how to perform some basic joins using R. So that if you're trying to combine multiple tables together, joins are really the simplest and quickest way to do so. So let's get started. Here's the setup here. Let me share that screen really quick. Okay, so I'm going to show you some examples here. So performing joins in R using the dplyr package. So all the functions I'm going to use in R, they're going to be coming from the dplyr package. Okay, so let's say I have this first table called activity. It's got the timestamp, patient ID, and activity, and then a location. Okay, so I have this first table, and I have the second table called patient. So for every single patient ID, it gives you the age and the gender as well. Okay, so knowing these two tables, I want to combine these tables into one. Okay, so how can we create a table output showing the activity and the patient info in one single table, which might be useful for us? Okay, so we don't want to separate these out into separate tables. We want to combine them into one table, often referred to as a join. We want to join the activity table with the patient table. How are we going to join it then? Okay, if you look at the attributes or the columns here, the patient ID is common to both. Keep in mind that the name of these columns are not relevant. So the patient ID column in patient could have been called something else. Same with the activity table. Well, what's important is that those two columns are basically the same columns, right? They are connected, right? So any, I don't want to go too deep into like database design here, but the patient ID column in patient, that column is basically the key. And then anytime you see a value showing up in the activity table for the patient ID column, that has to come from the patient ID column in the patient table. Okay, so there's reference integrity between those two columns. Okay, so we know we can connect these two tables using that field. Okay, so in R, when you're joining these two tables together, you need to have the column names be the same. Okay, in the traditional database design sense, you don't. But when you're trying to use joins, it's going to be much easier when you make that call, the join command, if those two columns have the same column name. Okay, the three types of joins we're going to look at is the left join, inner join, and outer join. So let's get started. So let's get what a left join does. Returns records that have matching values from B to A. Quick graphical way of thinking about this is that if I have table A with columns x1 and x2, and I have table B with columns x1 and x3, if I do a left join between these two tables, the resulting table will look like this. So you retain every row in table A. So every row, A, B, C, it's retained from table A because you're left joining with respect to table A. And from table B, you only keep the rows that have a matching field, basically. We're matching it based on column x1. Since in table B, we have the rows where column x1 equals to A or B, but not D. So the D row disappears, but the columns A and B are retained. We still retain row C from table A because we're doing a left join. So we keep everything in the first table, the left table A. And we only keep the rows in the right table B that have a matching value in the column that you're matching against. Okay, so this is a result. If you do a left join where you do A and B, A being the left table, and left join on X1, join matching rows from B to A. Okay, so how would you do this in R? The call is just left join. The left table, that's the first argument. B is the right table. And then which column are you going to use to join together? So let's give that a try. Okay, so let's go to R. Let's give that a try. So I'm going to call this one, let's call this, what's this, DF. I'll call it DF left join 1. Okay, so that's the left join, the first table, we're going to do it based on activity table, and then the patient table by, and then the column that's common to both is the patient ID column. Okay, so let's run that and let's look at the result. Okay, we can look at the head of DF left join 1. Let's see the first 6 rows. This activity column is a little big, so it's hard to see. So let's just click on it and view the whole thing. So you notice here, every single row here, it's going to find the matching patient ID and fill the age column and gender column together. Okay. If you look at the results, every single row is going to have a value for age and gender, because we know if you're going to be in this table, in the activity table, it needs the patient ID has to match up in the patient table. So this table, there won't be any missing values. Okay, so that's the left joining the patient table. The activity table with the patient table. Okay, so now I have these two extra columns now that I didn't have earlier. Okay, let me try something else here. Okay, why don't I copy the whole thing here? Okay, but now I'm going to switch the order. So I'm going to call this left join 2. Okay, and I'm going to switch these two, the ordering. Now, does that matter? Absolutely does. The ordering matters. It's very important here. Okay, so we're going to anchor on the patient table. So we're going to do it with respect to the patient table, right? So we just show you what the patient table looks like, the first 6 rows. Okay, so we're basically adding columns from the activity table into this table. Okay, but remember, not all of the patient IDs that appear in the patient table are in the activity table, right? So a lot of these rows are going to have NA or empty values in this case, right? So let's try this out and let's see what this looks like. Okay, so I'm going to run that line. Now you can kind of already tell if you look at the number of rows, DF left join 2 has 215,000 rows, where left join 1 only has 67,000. Let's look at a few rows here so you can kind of get a sense. You might have to look at the whole table. So it's a little hard to see here. So let's look at click on the table here. Let's see what this looks like. So these first, remember in the patient table, patient ID P00129426 appeared only once, but now there's all of these additional rows, right? Because you're filling these columns that we didn't have before in the patient table, timestamp, activity, location. It corresponds to this particular patient ID. Okay, so you have a bunch. Okay, I'll show you one more thing here. If you can scroll down quite, see it. So a lot of these patients in this table don't have any activity. They have no records in activity. So it comes out with basically NA values for those 3 columns, timestamp, activity, location, right? Because when we switch the order, when we do the left join with patient, comma, activity, now we're anchoring on the patient table, which we know the patient ID is way more patient IDs, unique patient IDs in the patient table versus the activity table. Okay, so this is the result we expected. Okay, so that's the left join. Okay, so it's a quick way to join 2 tables together. It's just a left join command. Okay, how about an inner join? What does the inner join mean? So it returns records that have matching values in both tables. So in this case, if you have table A and B, columns, the rows A and B for the first table A, they exist and they're matching rows in table B as well. But row C and row D do not exist. So if you do an inner join, row C will be dropped and row D would also be dropped. Okay, so the resulting data frame will look like this: 3 columns, because now you have X1, X1, X3. And then the 2 rows that are present in both tables is A and B. So this is my result. Okay, so it drops any values that are not rows that are not matching, right? Okay, so what's the call in R? Inner join AB by X1. In this particular example, this won't be too interesting, right? Because when you do a left join with activity and patient, it's basically doing the inner join here. But just for demonstration, let me just show what this looks like. Inner join activity, comma, patient by patient ID. Okay. So if you look at the result, every single row here is completely filled out. Okay. But we know this from the beginning, this is going to happen because every single patient in the activity table has to exist in the patient table. So we know every record has a matching record. Every record in the activity table, in terms of patient ID, has a matching record in the patient table. Right? So the inner join looks identical to the first left join we did. Okay, so that's how the inner join works. Okay, let's go to the final one, full outer join. Return all records from both sides. Okay, so if you have these 2 cases, A and B, again, rows B and C do not exist. So these 2 values, 2 rows do not exist, or they don't have matching rows in tables. But we still retain them. Okay, because we're doing a full outer join. Okay, and the column, since row C doesn't have a value for X3 because it doesn't exist in table B, it'll simply be replaced by an NA value. Okay, that's the result, and the call for it is just full join. Okay, full join AB by X1. Okay, Now, if you do a full join here, let's do the full join and let's do full one. Here, but let's do full join activity dot patient by patient. This is also going to be a very big data frame, right? Okay, so full 250,000. Okay, you can take a look what this looks like. Okay, so again, it's similar to the left join when I put the patient table first and then put the activity table. Okay, it looks basically relatively identical. Okay, so that's how quickly you can join tables together. You can totally imagine, like, let's say I had the activity table and the patient table. If I have more columns in this patient table, I could still just join and have all the values that attached, the associated, the corresponding rows from that page table, and you would just append the columns to this, and you can make one gigantic table, right? So joins are very easy to do, very, very effective, and very useful. Okay, so I hope you use them properly. Okay, so that's it. Hopefully this is helpful. And thanks for watching. Take care.